Hello everyone, let us see the next example of Fourier transform. The question is this is a very important question. Find Fourier transform of the function. Function is given e raised to minus a square x square where a is greater than 0. This is given thing. Hence, deduce that e raised to minus x square by 2 is self-reciprocal in the form of Fourier transform. Okay, there are two questions in this single question. First question, we have to find out Fourier transform of this function. After that, whatever the result we have found from this question, depend on that we have to show this function e raised to minus x square by 2 is self-reciprocal in the form of Fourier transform. That means after finding Fourier transform of this, we have to find out Fourier transform of this, and whatever the answer we are getting, we have to show that that answer is self-reciprocal, means this is the function after getting Fourier transform of this function is similar or same as that of this function. Okay, now let us see the first question of this thing. Find Fourier transform of this function. Let fx is equal to this function. Okay, this will be your let fx be the given function. You can exclude that step. Okay, let fx be the given function, and we know Fourier transform of the function. The formula for Fourier transform is f of s is equal to integration minus infinity to plus infinity fx e raised to I sx dx. Okay, the function fx is given function e raised to minus x square a square x square. Put this value here. We get e raised to minus infinity to plus the rest of the things as it is. Now we have to make some adjustments here to find out this integration. Okay, let us see one by one, step by step. Here base is same, that's why exponential indice gets add here. E raised to minus s square x square plus e raised to isx get add. It becomes minus into infinity dx as it is, e raised to single base minus s square x square plus isx dx. Okay, now next, okay, what we are going to do, just take minus a square common from this step. Okay, what we have to do, a square take common from this, what we get, minus a square, it becomes x square here, plus from here we take a square common, that's why we have to divide a square by this to this term. Okay, dx. Now next step, here see, this we have to convert this function into perfect square. Okay, obviously this is x square, that's why x will be the first term, and this x present in this term, that's why this will be the middle term of the bracket square, right? What is the bracket square formula? A plus or minus, suppose plus, bracket square is a square plus 2ab plus b square. How to find out this this from this? In the reverse step, this is the first number square, that's why x square is there, that's why x is the first number. Okay, now a say first term and second term present in the middle term, and this x is present in this term, that's why obviously it is a middle term. Now how to find out second term from this middle term? Just coefficient of this first term 2ab consists of second term. To find out this second term, divide this coefficient of the first term by 2, we get the second term. What is the second term coefficient of first term here? This is the first term, coefficient is is upon a square, that's why we'll divide this term by 2, because 2 is extra term here, 2 is the extra number in the bracket square, that's why is upon a square divided by this 2. This will be our second term. Okay, now the plus or minus sign depends on the middle term sign. This is middle term obviously, and this is minus. Okay, square is there. Now whatever the term extra we are taking, we have to add or subtract from this term. Okay, now expand this. To find out the extra term, you have to expand this x square minus 2ab, that is I s x upon 2 gets cancelled upon a square. This is these two terms. Now what is the last term? B square. What is the b square? Plus I square x square s square upon 4a raised to 4 be the b square. This term we are taking extra. What is I square? It is a minus 1, we know that is a complex number, that's why minus s square upon 4a raised to 4 is the extra term we are taking. That's why to cancel out this effect, we have to take plus this term extra. We have to adjust this term here, okay, to cancel out the square effect. Okay, now take this minus a square inside to the each bracket. What we get? Minus a square into this bracket as it is. This minus plus becomes minus a raised to minus a square. This a square gets cancelled with this a raised to 4. We get a raised to square here. Okay, this minus a square upon 4a square. This dx as it is. Now separate out this exponential here. This is e raised to whole indice is there. Okay, this exponential raised to this whole indices. Separate out these two terms by giving separate indices to x base e. What we get? E raised to this term as it is into e raised to minus s square upon 4a raised to square. Okay, why we are doing this? Because integration is with respect to x, and in this term x is not there. That's why this is totally becomes constant regarding this integration. That's why we on next time we can take outside this term and this term as it is. Okay, now this next step, take this a square and this bracket square combined together, we get e raised to minus as it is, square bracket, put the square bracket a into this bracket raised to square. We have combined this here. Okay, now we have to use the one integration, that is integration e raised to minus x square dx from 0 to infinity is root pi by 2. This is standard integration. We already noted down in earlier note. Okay, that's why from this integration we have to find out the value of this integration. That's why what we have to put here, it is minus infinity to infinity. We can convert it to 0 to infinity, depend on the even and odd function. But if you observe this integrand and this integrand, this e raised to minus is same and this total becomes x square. Okay, depend on that what will be our substitution for this integration. Now put this total term inside this bracket is equal to other variable t. Okay, this is substitution come from this standard integration. Now remember this. Now next step, as usual, solving the integration. A as it is constant, derivative of this with respect to x is only dx, because x, this term doesn't contain x. That's why a into dx is equal to t derivative is dt. Okay, now we have to check out the limits. Whenever infinity or minus infinity is there, most of the times limits are same. X minus infinity to plus infinity, new variable is t. When x is minus infinity, obviously t becomes minus infinity. If x is infinity, obviously infinity adds with any term becomes infinity. Okay, limits are same. Now put this substitution here in this integration, we get LHS side is f of s, Fourier transform is equal to this as it is term, minus infinity to infinity becomes again minus infinity to plus infinity, e raised to as it is minus as it is, this total we had put t and this square as it is, and dx becomes e raised to minus t square is there into dx becomes dt upon a. Okay, take a outside, but it is constant, and minus infinity to infinity e raised to minus t square. Now this this is our standard integration 0 to infinity, but this integrand is, we know one more a result here. If fx is even, this integration becomes middle value is 0 to a fx dx 2 times. If fx is even, and if it is odd, it value is 0. This integration result we already used so many times. Okay, that we use this here. What is this integration? E raised to minus t square is obviously a even function, because instead of t, if you replace minus t here, minus t square becomes plus t square, and integrand becomes as it is, as it is by replacing minus t by t in this integrand. That's why it is a even function. Therefore, using this integration result, this becomes 0 to infinity. What is the middle at the middle point of minus infinity to infinity? It's 0. 0 to infinity, this becomes 2 times e raised to minus t square by t square dt. Okay, now it is the standard integration whose value is root pi by 2. Okay, the rest of the terms as it is. 2 gets cancelled. Answer is root pi upon a into e raised to this term as it is. This is a Fourier transform we have just calculated for the function e raised to minus a square x square. This is the first question we have done. Okay, what is the second question? Hence deduce that e raised to minus x square by 2, we have to find out the Fourier transform this term using this result. Okay, what we have to do here? We know this function's Fourier transform, and how to find out this function Fourier transform? Just replacing minus is there, x square is also same here, just replacing a square by 1 by 2 in the answer, right? So therefore we get this is our answer, f of s, that is Fourier transform of e raised to minus x square. A square is equal to root pi upon a. This is our answer. Now put a square is equal to half in above result, that is a is equal to 1 upon root 2, taking square root on both sides. Put this value here. What we get? F of Fourier transform of e raised to minus x square as it is, and a square value becomes 1 by 2. It becomes minus x square by 2 is equal to root of pi upon a value is 1 upon root 2. E raised to minus s square as it is, 4 as it is, a square value is 1 upon 2. Okay, 2 to the 4, here e raised to minus x square by 2, and this root 2 comes to the numerator. Okay, therefore Fourier transform of e raised to minus x square by 2 is equal to, this is the constant number. Okay, and its Fourier transform is this Fourier transform, constant times e raised to minus s square by 2, and these two functions are similar. Both the functions are same or similar. That's why e raised to minus x square by 2 is the self reciprocal, is the mirror image, like a mirror image. Okay, is the self reciprocal under which function? Fourier transform. Okay, this will be our second question. Now let us see some properties of Fourier transform. Number 1, change of the scale property. This you can consider as another question. Okay, if suppose, what is the statement? If f of s, that is Fourier transform of fx is denoted by f of s or f of fx, then f of ax is equal to 1 by a. Fourier transform here replace s by a only. Okay, a not equal to obviously 0, because if a becomes 0, it becomes infinity. Now let us prove this property. Let Fourier transform of fx, f of fx is equal to, here you have to write first step, that is Fourier transform of fx is given by f of fx. It is integration, just we replace here by given function here, that is minus infinity to infinity fx e raised to I sx dx. Okay, this is our original formula. Now using this original formula, we have to just replace f of x by f of ax. That's why Fourier transform of f of ax is given by f of ax is equal to integration 0 to infinity f of ax, this function e raised to isx dx. Okay, now what is our main, we have to solve this integration to get this original Fourier transform. That's why obviously we have to put this ax is equal to another variable t. Put ax is equal to this, ax is equal to t. Take derivative on both sides. A dx is equal to dt. Limits are same for minus infinity to infinity. New limits are also minus infinity to plus infinity for t. Put this value, we get in the integration, we get f of ax is equal to integration in minus infinity to infinity. F of it becomes t, e raised to I s x becomes t by a into dx becomes dt by a. Okay, take 1 upon a outside, this becomes f of t, rest of the terms as it is, e raised to I s by a put together and t outside. Okay, now what is this integration means? See here, if this is the standard formula for f of x or Fourier transform of fx is given by this, okay, where x is here and x is here, that is called Fourier transform of f of x. Then what is this? This is t here, this is t here. Okay, f of s, this is s here, that's why here s here, but instead of s, what is here? S by a. That's why this is the Fourier transform of s by a, f of s upon a. This becomes this. That's why answer becomes f of, we know this, therefore f of ax is equal to 1 by a as it is, and this is the Fourier transform of s by a. Okay, this is a Fourier transform of f of s only. That's why what is this nomenclature? Everything is same instead of this s by a. That's why it becomes f of s by a. Okay, this is the first property. Now note, this is the note. This is same as for Fourier sine and Fourier cosine transform. Just replace the suffix here by s. This is this result is same for Fourier sine transform also, and this result is same for Fourier cosine transform also. Okay, now let us see next property. This is first shifting property. Like Laplace, Fourier transform also have similar type of properties. Now shifting property, f of x minus a is equal to e raised to I s a f of s, where f of s is equal to Fourier transform of fx. We know this. Okay, like Laplace transform. Okay, this is the Fourier transform. Now let us prove this property. We know Fourier transform of fx, that is f of s, is given by, this is the definition, minus infinity to plus infinity fx, this function e raised to I s, this s here, sx dx. Okay, we have to find out this Fourier transform. Replace function by f of x minus a here. Therefore f of, that is Fourier transform of f of x minus a is equal to this integration as it is. Instead of fx, we have to replace f of x minus a, e raised to isx dx. Okay, now again by earlier property, we have to make substitution of x minus a is equal to t. Put put x minus a only to t. Take derivative on both sides. This is substitution. Dx, a derivative 0 becomes dt. Limits are as it is. Okay. Now therefore above integration or above term becomes f of LHS is f of x minus a is equal to integration, same limits, f of this becomes t and e raised to I s as it is, and x becomes t plus a here. Okay, dt. Now separate this exponential because a I s is a constant here. Integration is with respect to t. E raised to I, rest of the terms as it is, e raised to I s t into e raised to I s a. Okay, there are total t terms in which this term doesn't contain t, that's why it is a constant. Regarding this integration, we take it outside. Therefore e raised to I is a integration minus infinity to plus infinity f of t here e raised to I s t dt, and this is the same integration as this integration. Okay, x instead of x, this is t is a dummy variable here. That's why this is called the Fourier transform of f of x, that is f of s. Okay, therefore Fourier transform of f of x minus a is equal to e raised to I s a f of s. Okay, you have to mug up all these formulas, this formula or earlier formula, this one. Okay, because it can be asked for objective type of questions. Okay, next property, let us see modulation theorem. Okay, this is one theorem here. Fourier transform of, we have to prove this theorem. Fourier transform of f of x into cos ax is equal to half into bracket Fourier transform of s plus a plus f of s minus a bracket complete. This we have to prove. Okay, let us start with the definition of Fourier transform. We know Fourier transform, that is f of fx, that is f of s, is given by integration minus infinity to plus infinity fx, this function fx e raised to I s x dx. Okay, now we have to find out this Fourier transform. That's why put this value here. F of fx into cos ax becomes, instead of fx we have to replace fx cos ax in the integration. We get minus infinity to plus infinity fx cos ax e raised to rest of the terms as it is I s x dx. Okay, now we know cos ax, we have to solve this integration to, and we have to reach here. Okay, now here cos x, we know cos x formula is e raised to ix plus e raised to minus ix upon 2. Okay, therefore we have to use formula here. X instead of x, here angle is ax, that's why it becomes e raised to I x, that is ax, plus e raised to minus I ax, opposite of this, divided by 2. This is the formula for, standard formula for normal trigonometry cos x. For sine, it is just minus upon 2i. Okay, now this, take 1 by 2 outside of the constant because it is constant, and fx into take e raised to isx inside to the term, we get e raised to ix into e raised to isx plus e raised to minus ix into e raised to isx, bracket complete, dx. Okay, now in this term, in these two terms, ix is the constant, common, and s plus a take together, that means e raised to I x take outside, in bracket remains s plus a, plus e raised to, here also I x are the common, in the bracket s minus a is the term. Okay, bracket complete into dx. Now separate out this into integration because we want these two terms. Therefore in half as it is, integration minus infinity fx into this term dx plus integration fx into this term dx. Okay, now if you find this integration, this is the integration f s. Okay, where s is here, and integration is integration minus infinity fx e raised to I s x dx. Now here what we get, minus infinity to infinity fx is same, e raised to I, instead of s, here s plus a is there, and in this term instead of s minus a is there. That's why this integration, if this integration is f of s, therefore this integration is f of s plus this a. Okay, and this integration is f of s minus a. Okay, and this way we get this result here. Now similarly, there are some results you can easily, like this, you can easily prove this. Note, f of s means sine transform of, Fourier sine transform of fx cos ax. This is the general Fourier transform. This is sine transform of fx cos x, is half into bracket Fourier sine transform of S plus A plus Fourier sine transform of S minus A. Same result as above, just replace here Fourier sine transform FSS. Okay. Now Fourier cosine transform of fx sine ax is equal to, in these two results Fourier sine transform get reverse. Half into a just bracket f of, here if it is c there cosine transform, then in the bracket Fourier sine transforms are there. Fs s plus a plus fs minus fs s minus a. And for fs, that is Fourier sine transform of fx sine ax becomes half Fourier cosine transform of s minus a minus Fourier cosine transform of s plus a. Okay, remember these terms or these results. Here to prove this result, you can use here formula sine ax is equal to e raised to ix minus e raised to minus ix upon 2I. Okay. Now let us see next example. Find Fourier transform of e raised to minus 2 bracket x minus 3 bracket square is there. Okay. Now we are going to use one standard Fourier transform of e raised to minus a square x square. Okay, mug up this formula for e raised to minus a square x square, because so many example in so many examples we are going to use this directly. Now we know Fourier transform of e raised to minus a square x square is, this is the result. Okay, e raised to minus a square x square is equal to root of pi upon 2 e raised to minus a square upon 4a square. Call that equation number 1. Now we have to find out first e raised to minus 2x square result. Okay, and after that we can find out this result by using shifting property. Okay, now first f of e raised to minus, just replace here x square we have to find. Now what we have to do here, just replace a square by 2. Okay, therefore put a square is equal to 2 in this above result, that is a is equal to, take square root on both sides, root 2. We get f of e raised to minus 2x square becomes root pi upon 2 e raised to minus a square upon 4, a square becomes 2. That's why answer is root pi by 2 e raised to minus a square upon 8. Call it as f of s. This is a Fourier transform of this e raised to minus 2x square. Now we are going to use this result. We know Fourier transform of f of x minus a is equal to e raised to isa f of s, which is equal to e raised to isa f of fx. This is the result we know. Okay, what is our function here? This function. That's why let fx is equal to e raised to minus 2x square, and a, what is a here in this our original equation? 3. Put a is equal to 3 and a is equal to 3. Put this value here, we get f of x minus a becomes f of x minus 3, which is equal to e raised to, this is our fx. Put here, what is x minus 3? We know fx. How to calculate f of x minus 3? Just replace x by x minus 3 here, which becomes e raised to minus 2 x equal to x minus 3 bracket square, rest of the terms as it is. Now we have to find out this in functions Fourier transform using this result. Therefore Fourier transform of f of x minus 3, which is equal to Fourier transform of this function, is equal to, by this result, e raised to is, a value is 3, f of fx is e raised to minus 2x square. Right, therefore it becomes e raised to, take 3 before I, e raised to 3is into this function's Fourier transform we have already calculated as this, root pi upon 2 e raised to I minus a square by 8. Okay, we have used here two results. First one is this and second one is this shifting property. Okay, this is called shifting property. Okay, Now let us see next example. Find Fourier transform of e raised to minus x square cos 3x. Okay. Now again we are going to use here this result where cos is there. Okay. Now let fx is equal to e raised to minus x square. Okay. Now we know, again we are going to use this result, f of e raised to minus x square x square is equal to this result. What we therefore put s square is equal to 1 here. Here s square is 1. That's why I put s square is equal to 1 in this result. We get f of Fourier transform of e raised to minus x square becomes root pi by 2 e raised to minus s square by only 4. S square is 1. Now already we have calculated Fourier transform of this. Now we are going to use this result, modulation theorem. Now Fourier transform of fx cos ax is equal to half into bracket f of s plus a plus f of s minus a, where f of s is Fourier transform of fx. Okay, where f of s is Fourier transform of xx. This is our standard assumption. Therefore, in this, what is a here? By this result, a is a angle's coefficient. Angle coefficient we want a is equal to 3. That's why here a is equal to 3 and fx, that is fs, is a Fourier transform of e raised to x square, that is this result we have already get. Now therefore Fourier transform of this by this theorem, by this modulation theorem, e raised to x square minus x square cos 3x becomes half, just replace a by 3, f of s plus 3 plus f of s minus 3. Okay, and what is f of s? Fourier transform of this fx, that is Fourier transform of this e raised to minus x square, that is, this is your fs. Okay, that's why half into bracket, what is f of s plus 3? This we know, this is f of s. How to calculate f of s plus 3? Just replace s by s plus 3 in this result. We get root pi by 2 e raised to, here only s minus s plus 3 bracket square by 4 plus, just replace s minus 3 here, we get root pi by 2 e raised to minus s minus 3 square by 4, bracket complete. Take root pi by 2 common, here we get root pi by 4 and addition of these two terms. Okay, this is the answer. So these are the some results or properties of Fourier transform, and depend on those we have studied some examples. Okay, now let us move to last point of this chapter. This is a very important point. Evaluation. We are going to evaluate the integrations using some using one identity, that is called Parseval's identity. Okay, Parseval's identity. Here are some 6 formulas are there. There are very easy formulas. Okay, now before that, let us see convolution theorem for Fourier transform. This is only statement, you can mug up this statement. Let fx and gx are two functions over the interval, obviously minus infinity to plus infinity. This is a statement of convolution theorem. We have already studied convolution theorem for Laplace transform. Okay, this is the convolution theorem for Fourier transform. Then Fourier transform of fx into gx is given by this integration minus infinity to plus infinity f of u g of x minus u du, where f of u is the given function and g of u is the other function. Okay, other functions, Fourier transform. Okay, here capital G should be there. Okay, x minus u du. Okay, this is similar as Laplace transform, and this is one result. Fourier transform of fx into gx is nothing but multiplication of both the Fourier transform f of fx into f of gx. This is another result for convolution theorem for Fourier transform. Okay, now let us see some formulas of Parseval's identity, which is very important point. Now these are some formulas. Okay, see first formula, 1 upon root pi 1 upon 2 pi integration minus infinity to plus infinity fs, that means Fourier transform. Let fx and gx are the functions. These are some regular nomenclature or notations such that Fourier transform of fx is f of s. Okay, Fourier transform of gx is g of s. Okay, these are the notations, and rest of the suffix c means Fourier cosine transform, suffix s means Fourier sine transform. These notations we already know. Now first result is 1 upon 2 pi integration minus infinity to plus infinity fs, that is Fourier transform of function square ds is equal to integration minus infinity to infinity mod of fx, mod means positive value of function, fx bracket square dx. Okay, this is a result for Fourier transform. Now second, 1 upon 2 pi integration minus infinity to plus infinity multiplication of two Fourier transform, fs into gs is ds is equal to integration same fx into gx, where fs is this Fourier transform and gs is this Fourier transform, this function's Fourier transform dx. Variables are, these are variables with respect to those we have calculated the integrations. Now next, these three are the similar, these two are for Fourier transform, rest of the are for Fourier sine and cosine transform. 2 upon pi, here coefficient is 1 upon 2 pi, here coefficient is 2 upon pi, integration 0 to infinity fcs bracket square ds. Fc means Fourier cosine transform, that's why the lower limit is 0, because for Fourier sine and cosine transform integration limits are from 0 to infinity, and for Fourier's transform integrations are minus infinity to plus infinity in the formulas. Okay, bracket square is ds is equal to integration same limits fx means this function's Fourier cosine transform here, bracket square dx. Similarly, this can be obtained by using, just replace c by s here. This result is same as this, just replace c by s here. Okay, now next, 2 upon pi integration 0 to infinity fss gss means Fourier sine transform of multiplication of two functions, ds is equal to limit same fx into this gx dx, where fss means Fourier transform sine transform of this function, gs means Fourier cosine transform of this function. This result and this result is same, just replace 2 by pi here and here 0 to infinity. Now last, same, this result and this result is same, just replace s by c here. Okay, these two results are same, 5 and 6, these two results are same, only you have to mug up one. Okay, that's why only 1 2 3 and 4, there are only 4 formulas, distinct 4 formulas, and here just replace s by c. Okay, what is c means Fourier cosine transform of this function, and gc means Fourier cosine transform of gx function. Okay, these are the some results. Now we next lecture we are going to see the examples, lots of examples depend on this Parseval's identity. Okay.